In this video, we'll show you how to build a professional ultrasonic rangefinder using the RP40 based on the Raspberry Pi Pico, a 3.2-inch TFT display, and the RCWL CCT55 ultrasonic sensor, which is also compatible with the popular HCSR04 and similar modules featuring echo and trike pins. We'll cover the wiring, display integration, and the necessary software, providing you with a complete guide to building a reliable distance measurement tool. This project is ideal for DIY enthusiasts, robotics projects, and IoT applications. The guest and author is Hesam Moshiri. He holds a master's degree in embedded systems design and is experienced in electronic design and digital marketing. He owns a YouTube channel named MyVanitar that talks about electronic projects and design measurement tips.
Hi friends, welcome on board for another project. This is an ultrasonic rangefinder circuit. Here is the hardware, the circuit board. It is powered using this USB Type-C cable, and here is the display, a graphical user interface of course. This number shows the distance between the sensor and the object, and this circular progress bar is to visually show the distance between the minimum and maximum detectable range. The maximum detectable range is 300 centimeters. So 171 should be somehow in the middle, a little bit higher, okay? Because the middle point is here. These two numbers define the threshold for the buzzer and relay activation. So 30 for the buzzer means if the distance is below 30, buzzer is fully active. Before that, the buzzer will signal. I will show you. And this 40 means if the distance is below 40, the relay, this one is active. And the relay might be connected to whatever AC or DC load. You can modify all of these parameters. Even this one, you can turn on and off the buzzer. You can move between the elements or the widgets using this push button. You can see the focus rectangle. It is similar to the tab key of the computer keyboard. For example, I enable and disable the sound and move to this buzzer and increase it or decrease it. Okay? And as simple as this. Really, programming this board was not easy, especially this LVGL libraries and these coding. So let me show you how it works. At the moment, 171 is the distance. Let me put my hand in front of the sensor. So come down. So the buzzer gives some signal. But if we go below, so below 4D, the relay is active. Do you see the red LED? And below 30, the buzzer is fully active. It works as nice as this. So to explain the hardware and the board, I should disassemble everything and show you the circuit and the components. So let me pause the video at the moment. Alright, I disassembled the connected hardware. Here is the main board. This is the 40-pin LCD display, flat extender, and here is the buzzer. Let me start from the main board and explain in the schematic. So let's put these components away. We don't need them at the moment. I start from the power input, this USB Type-C connector. You can power this board using your mobile charger, for example, or any other type of 5 volts regulated power source. These two pull-down resistors are to indicate that this USB Type-C is on the load side, but because the current consumption of this circuit is low, I have not soldered them on my own board. So it's up to you. You can solder or not to solder them, but be careful about these two resistors in your other designs. Anyway, the input voltage comes through this low-pass RC filter. you can see the components. This 1206 package resistor. This is to minimize the input noise because the input voltage comes from a switching power supply and it's noisy. It's much better that we reduce the noise. However, we should be careful about the voltage drop. The voltage drop on this resistor is acceptable for this LDO type regulator. This is the part number of the regulator. Is to prepare 3.3 volts voltage for the LCD display. This LED is to indicate that the regulator works and the input supply is at the correct level. These two capacitors are to stabilize the regulator. Let's go to the microcontroller board. This microcontroller board is named RP2040. It is manufactured by the Waveshare. The microcontroller, as its name says, is RP2040 from Raspberry Pi Foundation. The flash memory is 2 megabytes, and I think the SRAM memory is around 256K, if I'm not mistaken. By the way, such specifications make it suitable to build graphical user interface applications because flash and SRAM is critical for such applications. The clock frequency I think is around 200 megahertz without overclocking. Anyway, this Schottky diode here are to separate the 5 volts from the debugger input, this one, and the supply input because you might debug the board when you also supply the circuit. So this is mandatory to put something like this diode to isolate these two supplies. These two decoupling capacitors to reduce the noise. These two, I put them as close as possible to the VCC pin. This LED is connected to the GPIO27 and it flashes to show that the program works. Do you remember the previous step? That flashing LED was this one. And if this LED does not flash, it means the program has crashed and you should investigate. Let's go to the LCD, this one. So it's a 2.40 times 320 resolution. This is the resolution of the LCD. I have configured the LCD for SPI using these three resistors. When we use the SPI, we have to pull down the data pins. And I forgot that the controller for this LCD is this one, ILI9341. This is the controller for this LCD. Okay. These two capacitors are decoupling here. I'm not sure if you can see. Okay, these two capacitors, and these are the resistors here, and this is the connector for the LCD. 40 pins connector, and your most challenging point is to solder this connector because the pitch between the pins is pretty small. You have to use a microscope to solder this, and I suggest you to use a micro soldering station. It makes the job much easier. You can directly connect this flat cable to the FPC connector. However, for demonstration purpose, I use this flat extender. You are not bounded. You can directly connect this flat cable like this to the FPC connector. So let's go down what we have here. So this is the driver circuit for the relay, this one. This is the Schottky diode to protect the MOSFET, switching MOSFET against reverse currents of the relay. This is the pull down resistor on the gate pin to prevent this MOSFET from self oscillation. This LED is to show that the relay is active. Do you remember this red LED in the previous step? And this capacitor is to reduce the noise, switching noise of the relay, this one. So you will connect your load AC or DC to this terminal Here's the terminal, and this is the MOSFET here. Let's go down. And this MOSFET is to control the buzzer. This one, this 2-pin XH connector, and this is the MOSFET. The same pull-down resistor on the gate pin. And these two capacitors are for the module, this one. And you will connect your ultrasonic module to this XH connector. These two capacitors are decoupling here. You see the decoupling capacitors. And finally, these two MOSFETs are to translate the 5 volts logic to 3.3 volts logic, these two. Because you can find a variety of ultrasonic modules on the market. So I have built this logic level translator circuit for you. So it doesn't matter what type of module you use, 5 volts or 3.3, you can connect either one to this circuit. I suggest you to use 5 volts, the 5 volts type module, because the range is higher and the reflected numbers are also more stable. So 5 volts case is much better. So I think, yes, these two push buttons, I have configured these two push buttons by the pull-up resistor. So the activation means ground or 0 volts, these two push buttons. I covered everything, yes. So yes, I think it's enough. If you have any question, just let me know in the comment section. I hope you like this video. Don't forget to share and subscribe. We will do something else in the next video.